Hi mathematicians, and welcome to this video talking about sets. Now sets, as we know, are a collection of distinct elements that meet a set criterion, or that meet a criterion. So we are going to look at question number 7. The question asks us to first list all the sets of numbers, all the numbers in the sets, and then make a Venn diagram. So our very first step is to list all of the numbers that are in set P, set Q, and set R. So I'm going to write that down. So number 7, and I have P equals the factors of 10, and factors are numbers that multiply to give you a product of 10. So the factors of 10 are going to be 1, 2, 5, and 10. So 1 times 10 is 10, 2 times 5 is 10, and 3 is not a factor, 4 is not a factor, 5 is already there, so this set is complete. Okay? Next, let's list the factors of 18 in set Q. So Q equals all the factors of 18. So let's list them out. Can 1 divide 18? Yes. What about 2? Yes. What about 3? 18 divided by 6? Yes. Okay. Divided by 3 is 6. What about 4? No, we don't get a remainder of 0. What about 5? No, because it doesn't end in 0 or 5. What about 6? Yes. Okay. Because 2 and 3 are factors, but if you don't know divisibility rules, we will get to that throughout the year. All right, next we have 7, no, 8, no, 9, no, 10, 9, yes, okay, because the digits 1 and 8 add up to a sum of 9. 10, no, it doesn't end in 0. 11, no. 12, no. 13, no. 14, no. 15, no. 16, 17, 18, yes. All right, so these are the factors of 18. What about the factors of 45 are the elements for set R? So we have 1. What about 2? No, because it doesn't end in 0, 2, 4, 6, or 8. 3. Does the sum of the digits add up to a number divisible by 3? Yes, so 3 is a factor. What about 4? No. 5? Yes, because the last digit is 0 or 5. 6? No, because 2 and 3 are not factors. What about 7? No. 8? No. 9? Does the sum of the digits add up to a number divisible by 9? Yes. So 9. And then we have, so 5 times 9 is 45. 3 times what is going to give us 15? 45. 3 times 15, so that's a factor. And then 1 times what is going to give us 45, 45. So these are all the factors that we need to list. So did we take care of the first step, which was list all the factors in the set? Yes, I took care of that, okay? Next, I need to make the Venn diagram. Here I am going to have 3 different circles. 1 circle for a set P, 1 circle for all the elements in set Q, and 1 set for all the elements in set R. 1 circle for all the elements in set R. Okay? So I'm going to draw 3 circles. 1, 2, and then 3. And I'm going to label this P, Q, and R. Now, the most important thing is that I know what each of these regions represents. Okay? So let's look at these regions of the circles to see what they represent. This right here, anything that is here has to belong in set P. Does that make sense? So the entire circle, everything here is in set P. everything here is in set Q. Everything here is in set R. But then we get into this region, and 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 in this region. We have to know what they represent. So we learned about intersections, and we know intersections are the elements that are in both sets, so that they would appear in this space. Okay? So this right here is the intersection of P and Q. All right? This right here is the intersection of P and, what circle is it crossing? R. So this section right here. This section right here is the intersection of Q and R. Okay? But what about this one right here? This one we didn't talk about. This seems to be a region that is this in circle P? Okay. Does this belong in circle Q as well? What about in circle R? So this right here is the intersection of sets P, Q, and R. That means that any element that shows up in all of these goes right there. So let's fill out this first one first, all right? Which of these elements is included in every single set? Is 1 in every single set? 1, 1, 1? Yes. That means 1 is going to go right here. Okay? This is the intersection of every single set. This is in every single set. What about 2? Is 2 in every set? No. What about 5? No. What about 10? No. And if you already go through one set, you know that it's not going to appear in any other sets. So we don't have to worry about 9 or 6 or 18. All right. So that's for all sets. This is the intersection of every single set. Now this right here is just the intersection of P and Q. The intersection of P and Q without what element? 1, okay? So where do P and Q intersect? What do they have in common? Do they have a 1 in common? Yes, but that's already written down there, so I'm just looking for everything but 1 now. What about 2? Yes, so I'm going to put a 2 right here. What about 5? No. What about 10? No. So that's it. That's the only element that intersects both set P and Q, 2. Okay, now let's go to this one right here. This is the intersection of Q and R without 1. Okay, so anything that appears in Q and R without being 1, because we already have it there, is going to go here. What about 2? Is 2 in both Q and R? No. What about 3? Yes. So we're going to write 3 there. What about 6? No. 9? Is 9 in both? Yes. So we're going to write 9 here as well. What about 18? No, it's not there. All right? See if you can pause the video now and see if you can figure out what goes here. And then we'll check in and see when you're done. Unpause the video to check in. All right. So this is the intersection of what? P and R. So we're going to look at P and R. What do they have in common? We know they have a 1 because it's already there. But everything but 1 we're going to write here, okay? Do they have a 2 in common? No. What about a 5? Yes. So let's put a 5 there. And lastly, what about 10? No. So the intersection of P and R is going to include 5. Now we get into elements that are only in P. So in P, we already have 1, 2, and 5. What's the only elements that we haven't mentioned yet? In 1, 2, 5, the only element we haven't mentioned is 10. So that goes here. Okay? This is everything in P now. 1, 2, 5, and 10. Do you see that? 1, 2, 5, and 10 in P. Great. Let's go to Q. We have 1, 2, 3, and 9. What elements haven't we mentioned in Q? 1 is there. 2 is already there. 3 is already there. Is 6 already written in the circle of Q? No. So let's write 6 right here. What about 9? 9's already there. And what about 18? No. So let's put that in there. And then pause the video, see if you can write what goes in this section right here, in this region. Okay? All right, now that you've unpaused the video, let's see. We have 1, 3, 5, 9. What's left? 1, 3, 5, 9, 15, and 45 go right here. And that is how you fill out a Venn diagram involving sets when you have 3 different sets. In class we only talked about 2 different sets, but this is an example with 3 different sets. I hope this video helped to explain how to use a Venn diagram and put the elements inside their proper regions. Take care, mathematicians.